and begin our work on quadratic functions. All right, so there's 3 different forms we're going to talk about with quadratic functions today. You're most familiar with the standard form. That's the one you work with the most. Standard form for a quadratic function looks like this: ax squared plus bx plus c. Seen that plenty of times before. That's nothing new. Okay, so a, b, and c are just coefficients. In Algebra 1, most of the time those are integers. Algebra 2, we got into some of them being maybe fractions or something like that. Here, it's just kind of whatever's there is there. You know, it's a number. It's all that matters. And we know the graph of a quadratic makes what shape? The parabola, the U kind of shape. So it's either going to open this way or this way. One of those. Okay, and what decides that? You know, remember, positive or negative what? A. So if A is positive, then it opens up and has that point right there at the bottom is called the what? Vertex, and it is a minimum or a maximum? Minimum. All that stuff decided by A being positive. And then obviously if A is less than 0, it's going to open down. And that vertex is going to be a what? Maximum. A lot of this is review stuff. Nothing crazy. And, you know, that vertex. Minimum or maximum. That kind of thing. Okay. Would that be a local or an absolute minimum or maximum, the vertex? Absolute. It's not a local. It's absolute, because that graph is never going to, if it's quadratic, it's never going to turn back around. So it is a absolute maximum or minimum for that graph. The domain of quadratics, unless you're dealing with some sort of word problem situation where you can't have negative x values or something like that, your domain is typically negative infinity to positive infinity, all real numbers there for the domain. And then the range is dependent on A. If A is a positive number, it's going to open up, so our range would be from whatever the y value of the vertex is to positive infinity. If A is a negative value, it's going to open down, so whatever the y value of the vertex is to negative infinity. So your range is going to vary. Domain, though, should you stay consistently all real numbers, negative infinity to positive infinity. Okay, so when we were doing quadratics back in Algebra 1, there's some things we found. One of those things was the axis of symmetry. It was that imaginary line that went down right down through the middle of the graph that you could fold it and it would match up on each side. And we found that equation of the axis of symmetry by using that little formula, negative b divided by 2a. Okay. And that got you the equation of the axis of symmetry. And then we found the vertex from there. And the vertex is going to be the x values, negative b over 2a. The y values, just plug that in to the function and work it out. Not anything incredible about that. And then the other things that we found were the intercepts. What kind of intercepts can we have? X and y. The y-intercept is always, if it's in standard form, C. So it's the ordered pair 0, C. Okay. X-intercepts what are ways we can find x-intercepts? Put 0 in for y. And that gets us a quadratic equal to 0. Okay, so set equal to 0, set y equals 0, and solve. Well, if we do that, what are our options for solving? Factoring is always should be in the forefront of our mind. That's something that we can do quickly and usually easily. That sometimes works, but factoring doesn't always work. If factoring doesn't work, what's our next option? Quadratic formula. Quadratic formula. You might know it. Okay. X equals negative b plus or minus radical b squared minus 4ac or divided by 2a. If you have trouble remembering that, sing it to the tune of row, row, row your boat, and it works really great. X equals negative b plus or minus radical b squared minus 4ac divided by 2a. What does the b squared minus 2a? What? It was a special thing. What was it called? You may remember. The discriminant. You remember that? The discriminant discriminates what kind of answers you're going to have. If the b squared minus 4ac, the part under the square root, is a negative number, so it's less than 0, then what that implies is that we have complex solutions. And complex solutions don't show up as x-intercepts. So that also means no x-intercepts. Okay. So if you find the b squared minus 4ac and you find out it's negative, you don't need to go any further. You know it's not going to cross the x-axis. You're not going to find those x-intercepts out of there. Okay. Yeah, if it asks for what are the x-intercepts, you would put none in that place. And you would tell me that there are none. Then b squared minus 4ac. If it's equal to 0, then you're only going to have one real x-intercept. That one real x-intercept will be the vertex of your parabola if the discriminant is equal to 0. And then one last scenario is if b squared minus 4ac is positive. I'm going to give you 2 real x-intercepts or real zeros. One of the clues that you can use if you wanted to, decide if something would factor or whatever, is if the b squared minus 4ac is a positive number and a perfect square, like 4 or 25, 36, any of those kind of numbers. If the discriminant is a square number and positive, then your trinomial would have factored. Not that you have to factor it, but it is handy sometimes when you're trying to move from one form to another. We'll get into those in just a little bit. Okay, so all review stuff you've known for a couple of years now, hopefully. Let's look at a problem. Example A. F of x equals x squared plus 7x plus 12. Okay. Standard form. And in Algebra 1, I always make my kids go, what's A, what's B, and what's C? Turns out it's pretty good practice. That's helpful in all the, every level here. What's A? B and C. Okay, so we're going to find all of those things that we talked about there. We're going to find the axis, the equation for the axis of symmetry. And then we'll find the vertex And then we'll find our intercepts. Okay. So axis of symmetry, what's the little formula? Negative b over 2a. So that'd be negative 7 over 2 times 1, which is just negative 7 over 2. So our axis of symmetry is the equation x equals negative 7 over 2. I would not. Not unless there were decimals in the original problem. Now, when you go to graph it, you want to think about it as a decimal, but when you're reporting it, no, don't change it to a decimal. Okay? So since we have the axis of symmetry, that gives us what for the vertex? And we got the x value, right? How do we find the y value? Yeah, find f of negative 7 over 2. You gotta insert it into the problem. Be very careful there. I mean, you're welcome to use a calculator if you want to. I'm going to try to do it without one because I like a challenge. I just took the same value from the axis of symmetry. That's the x value of the vertex. And then I'm just replacing x with that in the problem. And then this one would be, thank you. And then negative 7 or negative 49 over 2. All right. Thank you. Different color. Plus 12. Okay. Add those up. I'm gonna swap them. So that's gonna be negative 98 over 4. That'd be negative 49 over 4 plus 48 over 4, which is what 12 is, which is negative 1/4. And you can use a calculator to help you get that. That's not a, so the y value is negative 1/4. So there we have our vertex. Again, calculators more than legal on this. So. All right, intercepts. Start with the easy one, the y-intercept. We know from our equation, since it's in standard form, what's the y-intercept? 0, 12. The ordered pair 0, 12. And then we can do x-intercepts by taking the equation and setting it equal to 0. And you solve it by whichever method you want to. I mean, this is something you should know how to do. I'm going to factor it as x plus 3 and x plus 4. And then I set each factor equal to 0. And I get x equals negative 3, x equals negative 4. So nothing. So my ordered pairs would be negative 3, 0, and negative 4, 0. If you wanted to do quadratic formula, you could. Yes, ma'am. What multiplies to be 12 and adds to be 7? 4 and 3. Factoring. That in algebra we use that X method thing. I just did that in my head without, where you put the 12 up here and 7 down here, 4 and 3. That's what I did. I just didn't write it down. Okay. All right. What's our domain? All real numbers. So negative infinity to positive infinity, or if you wrote the set notation for that know that too. Range for this one. You got to think about which way is it open. Not 12. It opens up. 12 is our y-intercept, not our minimum value. Since it opens up, we have a minimum where? There's our minimum. So it's from negative 1/4 to positive infinity. and we're going to put a bracket on the -1/4 because it's included in our graph. It's our vertex. It's where everything's happening. Range from -1/4. Your range is always going to include the y value from your vertex. Always. Keep that in mind. All right. Okay. So there's standard form. We'll go to the next form. You don't have as much experience with this one, but you've seen it before. It's called Vertex Form. And you may see a textbook somewhere in your future that says shifted form. They're the same thing. Vertex form and shifted form, they're the same. Okay. Vertex form is really helpful in finding the vertex and the axis of symmetry without having to do any work. The way that's set up, you've got that A value. That's the same A value that we have with standard form. Nothing's different about it. It still sets all the rules about opening which way, up, down, that sort of thing. So A is still A. And then we have x minus h squared plus k. I remember seeing that in algebra, well, at least for sure algebra 2. You saw that some. So vertex form, you've got this stuff going on. Well, some of the things that already happened with standard form still happen here. A still decides if it opens up or down. If it's positive, it opens up. If it's negative, it opens down. That hasn't changed. Doesn't ever change no matter what form of the quadratic you got. What changes is how you find your vertex, your axis of symmetry, and intercepts and stuff like that. Okay, so that changes a little bit here because it's not in the standard form. So when you go to find your axis of symmetry, it's actually easier if it's in vertex form. The axis of symmetry will be at x equals h. And your vertex will be at the ordered pair hk. So whatever's inside the parentheses, it's the opposite when you pull it out. So if it were -7, then the axis of symmetry would be at +7. Okay. The k on the outside for the vertex is exactly what it is. So if it's +5, it's going to be +5. If it's -6, it'd be a -6 on the k value. So vertex form, it's got the vertex written right there for you. That's why it's called vertex form. Shifted form would be like taking the x squared function and shifting it h units left or right, and then k units up or down. That's why some books call it shifted form. We usually call it vertex form. What are the h on the inside of the parentheses? It's the opposite when you pull it out. So if it's a plus in there, when you pull it out, it's a negative. If it's a minus in there, it's a positive when you pull it out. Yes. The inside of the parentheses is where crazy things happen. All right. So intercepts, not quite as easy here. The y-intercept was super easy when it was in standard form because you just looked at the C and you got it. That's not the case here. You're going to have to plug in, what to get the y-intercept. Plug a 0 in for x. You're just going to find f of 0. So the ordered pair would be 0, and then f of 0 would be the y value. So you just plug a 0 in for x and work that thing out, and you're going to get the y-intercept. So a little bit more work on the intercept there for the y-intercept. X-intercepts, you set the thing equal to 0. And then my suggestion is solve by square roots. So move k over, divide by a, and then take the square root of both sides. And we'll do an example in just a second. I'll show you that. But that's my suggestion, is solve it by square roots. You could multiply it out and put it back in standard form and then use quadratic formula. But that seems like a lot of extra work to me. But it still gets you the same answer. Okay. And if you're gonna be one of those people that uses quadratic formula every time, and there's nothing wrong with that, it's just gonna take you longer for some problems than others. Don't forget, when you square this binomial, it's x minus h times x minus h, FOIL method thing, distributed properties twice. Okay, so don't mess that part up because it will mess up the rest of it if you do it that way. I'm going to do it by square roots because it's faster and it's not that much more difficult to do. So let's look at an example of that. Whoa, wait, sorry, I forgot. Domain. What's the domain of a quadratic? All real numbers. Negative infinity, positive infinity. The range. What about our range? Exactly. It'd be from K to positive infinity if A is what? Bigger than 0. If A is positive, it'll be from that K, that vertex value, the Y value of the vertex, to positive infinity if A is positive. If A is negative or less than 0, it's going to be from negative infinity to K. We can be a little bit more specific on this one because we know that value. It's K every time if it's in vertex form. So we can be a little more specific about the general idea of range there. Okay. Let's look at an example. Example B, g of x is equal to 2 parentheses x minus 3 squared plus 4. Nice vertex form for that, which makes things fall out quickly. The axis of symmetry, I'm just going to abbreviate there, tired of writing symmetry out. So the axis is going to be x equals what? What was that? I heard somebody say. Is it positive 3 or negative 3? Positive 3. Remember, you take the opposite of whatever's in there, and when you pull it out, that's what it's going to be. So the opposite of minus 3 is plus 3, positive 3. So that's our axis of symmetry, which means our vertex, again, we don't have to do any work because it's in vertex form. What's the ordered pair for the vertex? 3, 4. It's that easy, guys. Don't overthink this. Intercepts, this is not as easy here. So let's find the y-intercept. It doesn't matter what order you find the intercepts in. I just tend to do the y one first. So f of 0, or in this case, g of 0, sorry, let's name that. 2, 0 minus 3 squared plus 4. So that'd be 2 times 9, 18 plus 4 is 22. So 0, 22. Across the y-axis at 22. Good ways up. Now, x-intercepts. So I'm setting the problem equal to 0. We got 2 x minus 3 squared plus 4 equals 0. And I'm going to solve that. I'm going to do it by square roots. So I'd subtract 4. And I would divide by 2. And then take the square root of each side. That gets me x minus 3 equals plus or minus I radical 2. What do we know about x-intercepts at that point right there? Why? Because the number we're taking the square root of was negative. That gives us a complex solution. Complex solutions don't cross the x-axis. Yes, yes. So we could go ahead and finish that off and get x equals 3 plus or minus I radical 2. Those are the zeros, but they're not x-intercepts. So the x-intercepts, you would report none out of that. Even though there are zeros, there are no x-intercepts. Those don't show up. If you graph that equation with your calculator, you're going to see that. So if I graph 2 parentheses x minus 3 squared plus 4. You see that parabola there opening up. It doesn't cross the x-axis. You should, you recognize that. The graphs and the equations all go together. Don't forget, you got that tool that you can use to help you kind of know, hey, I don't even have to do the x-intercept. I know it doesn't cross because I saw it on the graph. So that can help you a lot. Okay. All right. So there's vertex form. Let's get the last form. And this one, you've got experience with it, but we didn't call it this when we were doing this in Algebra 1 and 2. We call it intercept form in here. And you may or may not have been told that that's what it's called. A lot of times we use the words factored form. And that's where you have a function. You got that a, the same a from standard form. It still does the same stuff. It decides whether this parabola opens up or down. And that hadn't changed and won't change. And then you have these factors. Okay. That is intercepts also. Because if it's in factored form, to find the x-intercepts, what do you do with each factor if you've got a factored form of a polynomial? Yeah, you set them equal to 0, you solve for x on, and that gets you the intercept. So that's why they call this intercept form, because it's so close to getting the x-intercepts. Okay, not very close to getting the y-intercept, but it's very close to getting the x-intercepts because it's in the factored form, and all you got to do is set each parenthesis equal to 0 and solve it. You've got the x-intercept. So that's very simple. Now, my suggestion, there are some shortcut formulas, but honestly, they're a little obscure as far as memorizing them. So I don't even do them that way. My suggestion to find all of those other things is multiply into standard form. To get the axis, the symmetry, and the vertex, that's what I would do. Multiply it to standard form, then use negative b over 2a. And it's going to work out much easier than trying to memorize some formulas for that. Okay. Let's look at an example that's in intercept form. Example C. H of x equals negative 6, x plus 7, x minus 8. Original with my numbers 6, 7, and 8. Now, which way does this parabola open? Down. We know that because why? Negative 6 in the front. Okay, so we know that that's going to have the vertex be a what? An absolute maximum, because it's gonna have the highest point. Okay, so we just knowing those general information things about it are important. Okay, so since it's in intercept form, I'm going to start with those and then go back and get the axis of symmetry and the vertex. So if it's in the vertex form, obviously the place to start is the axis and the vertex. If it's in intercept form, the obvious place to start is intercepts. So I'm going to start there. To find a y-intercept, what do I do? Let x equal 0. So find h of 0. So when I do that, I got negative 6 times 0 minus or plus 7, and then 0 minus 8. So I've plugged that 0 in, and then I'm just working that out. So negative 6 times negative 8 is positive 48 times 7 be 280 plus 56, right? And 280 plus 56 would be how much? 336, is that right? Yay. So just plugging that in. The negative 6 was the a from the original, and then the zeros just give you those values back. So 7 times negative 8 times 6. or negative 6. So our y-intercept is at 0, 336. So really, really high on the y-axis. This definitely wouldn't be one that graphing it would be how I would get my y-intercept. Sometimes that is a handy thing. X-intercepts should be even easier. So we're going to take that equation, set it equal to 0. Well, I'm going to get rid of that negative 6 by dividing. So that gives me x plus 7, x minus 8 equal to 0. And then what do I do with each of those factors? Set them equal to 0. So x equals negative 7, x equals 8, so negative 7, 0, 8, 0. Those are our x-intercepts. This. Not bad. Pretty easy right there. Intercept form makes that super easy. And then from there, I'm going to multiply this thing out to get my axis of symmetry. So I'm going to multiply these two together first. That'd be x squared minus 8x plus 7x minus 56. That's negative 6 times x squared minus x minus 56. And then distribute the negative 6. So negative 6x squared plus 6x plus 336. Shouldn't be a surprise that it's 336 for C, because what's our y-intercept? 336. Those match up. There's a place to check to make sure you multiplied it out correctly. All right. Now, from there, we can find our axis of symmetry by just doing negative b over 2a. So negative 6 over 2 times negative 6 would be 1/2. All right. So our axis is at x equals 1/2. And then we can find our vertex by just plugging that in. 1/2 and then something. H of 1/2. Negative 6 times 1/2 squared plus 6 times 1/2 plus 336. So 1/2 of 6 is 3. 3 plus 336 is 339. And then negative 6 times 1/4 be negative 3 over 2. So we're subtracting 1 1/2 from 339. That would be so 339 times 2 to get the common denominator to be 678. Is that right? 660 and 18, 678. Minus 3 be 675. Yeah, I'm adding 339 to negative 3 over 2. I get 675 over 2. And you can use a calculator, right? You don't have to do it in your head. Just try not to go over there and punch buttons, because it can be done. Okay, what's our domain? All real numbers, negative infinity, positive infinity. Nothing changed about that. What's our range? Is it 675 over 2 to positive infinity, or negative infinity to 675 over 2? Because which way does this thing open? Down, because of the negative 6 in the front. There's a domain and range of that. Keep in mind, guys, they can still ask the same questions they asked back in chapter 3 about where's the function greater than 0. So you got to think, okay, well, which way is it open? Where are the x-intercepts and getting that interval stuff? They can still ask that kind of stuff. One of the other things they can ask here with this is the last problem for today is write the equation. Right, I becomes 14. Of the quadratic. Through ordered pair time, 3, 0, negative 5, 0, and 0, 8. Okay. So when they give you a question like this, you've got to be conscious of what they're asking or what they're giving you. We know what they're asking us to do. They're asking us to write an equation, quadratic. And we're going to write it in all three forms. But let's start with the best form. Okay. What do we know about all three of these points? They're what? Intercepts. Okay. So that would imply we need to start with which form? The intercept form. Okay. Now, which ones are x-intercepts? Yeah, 3, 0, and negative 5, 0. The 0, 8 is the y-intercept. That's not in intercept form. So we're going to use the x-intercepts, and then we're going to use the y-intercept to help us find a. Okay, so we'll start with intercept form. We'll just call it f of x. We don't know what a is, but we know that one of the intercepts is positive 3. So what's the factor that goes with positive 3? X minus 3. What's the factor that would go with negative 5? X minus negative 5, which is actually x plus 5. Okay. Almost intercept form. We don't have a yet, but we have another ordered pair to use. We got 0, 8. That's an x and a y, right? In our problem, if we replace x with 0 and y with 8, there's only one variable left. It's a. So I'm going to do that and find a. 0 minus 3, 0 plus 5, and 8. So negative 3 times 5 is negative 15. So that's negative 15a equals 8. We divide by negative 15. A is negative 8 over 15. So our function in intercept form is negative 8 over 15, x minus 3, x plus 5. There's intercept form. What would be the next form we would want to go to? If we've got intercept form, what's the next easiest one to go to? Standard, because we can just multiply that out and we got standard form. So that's what we're going to go to next. So if I multiply that out, that's going to be x squared minus 3x plus 5x minus 15. And all that's going to be multiplied by negative 8 over 15. So f of x equals, that'd be 2x. It'd be negative 8 over 15 x squared minus 16 over 15 x plus 8. Standard. Well, that's wonderful, but we got one more form to go with. We got vertex form. So what do we need to find before we can write it in vertex form? The vertex. We got a formula that helps us find the vertex, right? You could do completing the square here if you feel like you've got that in your toolbox. You can. It's about the same amount of work, so I'm going to do it by finding the vertex. So negative b, so 16 over 15 divided by 2 times a. So that ends up being negative or 16 over 15 divided by negative 16 over 15, which would be what? -1. You divide 16 over 15 by the same thing, and it's just negative. So -1, that's our axis of symmetry. But it's also what? The x part of the vertex, right? So we can take that and find the y part of our vertex. Pretty easy. F of -1, -8 over 15, -1 squared, minus 16 over 15, times -1 plus 8. So that's going to be -8 over 15 plus 16 over 15 would be -8 over 15 plus 8. 8 turns into 80 plus 40, 120 over 15. Is that right? That ain't right. I'm going to break down. I'm going to do it. -8 over 15 plus 16 over 15 plus 8. Math, enter. 128 over 15. Right there. From this. Well, when I square -1, it's 1. And 1 times that's just that back. So our y value is 128 over 15. So vertex form. We got H and K now.
To announce those FFA students who ordered donuts to be delivered, they will be in today. You will need to pick them up. Thank you.
And there we have vertex form. We got all 3 forms out of that. Okay. And notice I've changed that to +1 because it was a negative.
Ashley Schreiber reports to office.
All right. If they give you the vertex as one of your ordered pairs when they ask you to write the equation, guess what form you start with? Vertex form. They give you something nice. They'll give you the vertex and one other point so you can find A. It'll take a little practice for those problems. Most of the other ones are review stuff, so you'll have to kind of work with that. But pretty good review of quadratics in that section. So we kind of split that in algebra 2 and stuff.